25 light-years away from Earth, in the constellation Lyra, there's a young star, Vega. The brightest and one of the most famous, this star is twice the mass of our Sun. Vega is so brilliant, you can see it even at twilight when all the other stars disappear from the sky. Despite all the star's fame, astronomers have never seen a single planet orbiting Vega, until recently. Researchers have been observing the star for a decade or so when they spotted a curious signal. It might be Vega's first world we'll know about. If it did exist, it'd be a marvelous place. The planet would likely orbit so close to its host star that one day on it would last around 2.5 Earth days. The world would be the size of Neptune, and this ice giant is 4 times wider than Earth. Or it might even be as large as Jupiter. But the most impressive thing about this potential planet would be its temperature. The place could turn out to be the second hottest world known to scientists. On its surface, it'd be as hot as 5,400 degrees Fahrenheit. For comparison, the temperature on the surface of the hottest planet in the solar system, Venus, doesn't rise above 900 degrees Fahrenheit. The only place hotter than Vega's potential companion would be Kelt 9b. The temperatures on this exoplanet don't drop below 7,800 degrees Fahrenheit. Anyway, the candidate world would be closer to Vega than Mercury in our solar system is to the Sun. It could result in the giant planet puffing up like a balloon, and then even metals would melt in its scorching hot atmosphere. Unfortunately, the existence of the sizzling planet has yet to be confirmed. Astronomers think that the easiest way to prove it is by trying to spot the light emitted by the unusual planet. And since we're talking about planets, are there any worlds out there that resemble Earth? Astronomers have discovered and confirmed more than 4,000 exoplanets, but it's no secret that thousands of other candidates are still waiting for their turn to be detected. Of course, not all of these planets are like our Earth, but some are. For example, Gliese 667 cc. This world is only 22 light-years away from Earth. Scientists aren't sure if the planet is rocky, but they know the place is more than 4 times as massive as our planet. The star of Gliese 667 cc is a red dwarf. That's why it's much cooler than our Sun. So, the exoplanet is likely to be in its star's habitable zone. But this idea hasn't been confirmed yet. The Earth-like planet might be moving too close to the star. Then it can be regularly baked by its flames. Kepler 22b is much farther away than the previous world. If you wanted to reach that planet, you'd have to travel 600 light-years. This world, which is more than twice as large as the Earth, lies in the habitable zone of its host star. But it's unclear whether it's liquid, gaseous, or rocky. Kepler 69c is almost 70% bigger than our planet. It's also very, very far away, 2,700 light-years. It'd take you 54 million years to travel the distance that great in a modern spacecraft. Researchers aren't sure what Kepler 69c consists of, but they think it's likely to lie in the habitable zone. The planet's position in its solar system is like that of Venus and ours. But since the host star is only 80% as bright as the Sun, the planet shouldn't be affected by its heat that greatly. Kepler 452b is the most Earth-like planet astronomers have discovered so far. It resides 1,400 light-years away from our planet. Its host star is very similar to our Sun, and the planet, lying in its habitable zone, is 1.5 times the size of Earth. Scientists also think that Kepler 425b is likely to be a rocky world. Are any of these or other planets besides Earth suitable for life? There are 24 potentially super-habitable planets, and one of them met not one, but 2 criteria astronomers have for such worlds. KOI 5715.01 is 5.5 billion years old and around twice the size of Earth. It orbits an orange dwarf a bit less than 3,000 light-years away from our planet. Its surface temperature might be 4 degrees Fahrenheit cooler than that of Earth. But since the planet's atmosphere might have more heat-trapping gases, the place is likely to be super-habitable. Another potential super-habitable planet is KOI 5554.01. This world is a bit older than our planet, 6.5 billion years against our 4.5 billion. The exoplanet's size is likely to be the same as Earth's. The planet orbits its host star, a yellow dwarf, and the average temperature on its surface is 80 degrees Fahrenheit. What planets are visible from Earth? Mercury is the nearest to the Sun in our solar system, but since this planet is so close to the star, You can only see it just after sunrise, in the early morning, and at dusk. From up close, the place looks a bit like the good old moon. The planet doesn't have an atmosphere, and the temperatures on its surface are extreme, 800 degrees Fahrenheit during the day and minus 290 degrees Fahrenheit at night. Venus is the second brightest celestial object out there after the moon. It's one of our planet's closest neighbors. Also, it's the most similar to Earth in terms of gravity, size, mass, and average density. Unfortunately, you won't be able to see Venus's surface from Earth. A thick layer of clouds is securely hiding the planet. Jupiter can be either the third or fourth brightest object in the sky. It depends on Mars, which occasionally shines brighter than the gas giant. You can see Jupiter especially well in the summer. The gas giant's most famous feature is the Great Red Spot. That's an enormous storm that has been raging on the planet's surface for centuries. Even though the largest planet in the solar system looks like a solid sphere, you wouldn't be able to land on its surface. Jupiter is mainly made up of gases, mostly helium and hydrogen. Saturn is the second largest planet in the solar system. It's the last one of the 5 planets you can see from Earth with the unaided eye. Saturn is incredibly far from Earth, but its unique rings help you instantly recognize this colossal planet. It's a pity that Saturn's trademark feature is only visible in a telescope. By the way, more than 700 Earths would fit into Saturn. At the same time, the gas giant's density is a mere 1/8 of Earth's. This is why Saturn's mass is just 95 times greater than that of our planet. What planets in the solar system are closer to each other than the rest? Astronomers believe that Mercury is the closest to any other planet in the solar system. And that's quite shocking because, how about Venus? It orbits the Sun between Mercury and Earth. Isn't it supposed to be closer to our planet? Venus is indeed rather close to Earth, but only for a very short period in its orbit. The rest of the time, Venus is much farther away. But Mercury's orbit doesn't let the planet move too far away from the Sun, and it's closer to Earth more than 50% of the time. The same principle works with other planets too. Even gas giant Neptune is farther from Uranus than from Mercury. Most of the time, the 2 larger planets are on the opposite sides of the solar system. Their orbits sometimes do bring them very close to each other, but it happens very rarely. And how about planets outside the solar system? Astronomers have recently discovered 2 worlds traveling around the same star. Their orbits are often so close to each other that each planet looks like a huge full moon from the surface of the other. It occurs every 97 Earth days. These planets are about 1,200 light-years away from Earth. Their composition and size are different, but the distance between them is a mere 1.2 million miles. That's 5 times the distance between Earth and the Moon, and it's closer than any other planets astronomers know about. One of the newly found worlds is more than 4 times as massive as our Earth. It's likely to be rocky. The other is a gaseous planet the size of Neptune and almost 8 times as massive as our planet. Scientists haven't figured out yet how such dramatically different space bodies ended up in such similar orbits. The universe is not static. It evolves all the time and grows in all directions. It's expanding, and scientists found this out almost a century ago. And it's not at a stable rate. The more time goes by, the faster the universe expands. As this happens, stars, planets, and galaxies move farther and farther apart, which leaves more space between them. If that's the case, the universe is supposed to become colder as it expands, right? After all, it was a lot denser when the Big Bang happened, and a lot hotter. As it was expanding, space was cooling down, which created conditions for planets, stars, and other space objects to form. Yeah, that's not exactly the case now. Scientists were surprised to hear it too. But our universe is actually getting hotter. They observed the temperature of cosmic gas farther away from our home planet compared to young gases closer to the Earth. Since we measure distance in space by light years, farther areas are like going back to the past, and regions closer to us are like observing the present day. They found out the temperature of a gas in space has gone up more than 10 times in the last 10 billion years. Now, the temperature of the cosmic gas that's spread all across the universe can get to around 4 million degrees Fahrenheit. Wow! As the universe expands, gravitational force does its part and pulls gas and dark matter together. It's doing some pretty hard work there. It creates galaxies and clusters of galaxies out of them. And this process is totally chaotic. It's so messy that more and more gas heats up as all of this is happening. Space was extremely hot when it was just forming 13.7 billion years ago. What if it gets warm like that once again? Scientists are observing the situation. They found out the temperature in space increased by measuring cosmic gases using something called redshift. They generally use this method when they want to see how far away some space objects are. Those that are closer to us have shorter light wavelengths. The farther some object is, the longer its light wavelengths are. And they can now determine the temperature of a certain object from its light. On average, space is a pretty cold place. The glow that's left from the Big Bang is called the CMB, which is short for the cosmic microwave background. It's so powerful and intense, it bathes the entire universe in light. It's the only thing that significantly heats up matter. But there are many smaller mechanisms that help to heat up matter in the universe, and they could go crazy if space warms up, like stars. They emit radiation that affects nearby dust and gas. They radiate throughout the far infrared too. When a star is at its early stage, the radiation coming from it forms protoplanetary structures that look like disks. They primarily form in a single plane, and a bright central star produces spectacularly illuminated gas, and there are blue reflections of this gas. It was like that with our planetary system too. Strong energy and gravitational forces cause collisions, dust, and gas in an uncontrolled vortex that's forming planets. That's why most planets in our solar system orbit in the same direction. That's the direction this giant whirlpool was spinning a long time ago too. Active stars, colliding galaxies, stellar cataclysms, black holes, neutron stars. The universe has so many sources of energy. And when you surround normal matter in space with such an energetic environment, it heats up drastically. When you heat something up, it radiates that energy away in a certain way. In most cases, galaxies have just a couple of areas where stars are forming, at regions where gas is collapsing. A bubble that surrounds that area contains ionized hydrogen. 3/4 of our sun is hydrogen. Thanks to that hydrogen, the sun keeps us warm. In its core, hydrogen transforms into helium and causes atomic fusion. Yep, that's how our sun releases its energy. Radiation heats all that gas to thousands and thousands of degrees. At the same time, it ionizes a large number of atoms and molecules, which basically means it turns them into ions. Atoms are neutral particles, and ions are either negatively or positively charged particles. If the universe heats up, our sun might too. If its temperature hits 30,000 degrees Kelvin, it could become hot enough to ionize all those materials it had previously ejected, and it could create a real planetary nebula. This would be a nebula in the shape of a ring that forms because of an expanding gas that surrounds an aging star. As the temperature goes up all the time, hydrogen ionizes. At a few thousand degrees, this could turn the nebulae in our solar system pink with emission lines. Our sun could come to its end if it reaches the temperature of 50,000 degrees Kelvin. If you could float in space and come closer, you'd see it glow in eerie green tones because of doubly ionized oxygen. Higher energy phenomena make more galaxies collide. This heats gas even more and eventually results in X-ray emissions. What about black holes and radiating neutron stars? When they go crazy, they can shape whole galaxies, and who knows what more. Maybe we'd have more masers too. Those are natural lasers our universe produces. They arise when big populations of molecules receive large amounts of energy. By now, scientists have found the strongest, yet the most distant maser. So powerful, it's more luminous than the light 6,000 suns would produce, and in just one emission line. Maybe then we'd discover even stronger masers. That's in the case that we're even going to be here at all, because as the universe is getting hotter, cosmic radiation is getting stronger. Not so good for life on Earth. Increased cosmic radiation could harm us. Who knows if life would even be possible on Earth in that case, or if the powerful gravitational force would pull our home planet too, and crash it into another one. But maybe life as we know it wouldn't completely disappear. Or If that happened, it could possibly somehow find its way once again, maybe in the distant future. There's a possibility our universe could support life at its early stages. Doesn't look like that when you think of the chaos the Big Bang caused, right? But that was only in its mere beginnings. After things had settled down a bit, the dregs of enormous, earliest stars formed rocky planets. In our solar system, those are Earth, Mars, Mercury, and Venus. You can't set your foot on the rest of them since they're gas giants. Back in that time, radiation was quite intense, so rocky planets had an adequate environment to form, since it takes a lot of energy to whirlpool dust and particles and bake a planet in the end. This period of time coincides roughly with that when the first stars formed in our universe. Ancient stars were way bigger than our sun. They lived shorter, though. They would have just exploded as supernovas on their end, and they would leave heavy metals across the space around them. Those are the particles rocky planets formed from. Radiation spread around the whole universe back then. It has changed over time. Today, it's almost an absolute zero. 400,000 years after the Big Bang, when hydrogen atoms were forming, CMB was almost as hot as the surface of our sun. And about 15 million years after the Big Bang, its temperature was close to room temperature, which is around 80 degrees Fahrenheit. These things were happening across the universe, so there were many planets that could potentially hold life. If we were one of those ancient worlds, we wouldn't need a star to keep us warm. CMB would be enough to do it. So, it's possible that life in space is way older than we think it is. There could have been ancient worlds with liquid water on their surface. What if there were some primitive forms of organisms, like on our home planet a long time ago? Or even more developed ones? Perhaps we'll find out one day.
Hey, ready to test your knowledge? Of course you are. You'll get 1 point for each correct answer. So, without further ado, the sun is yellow. Do you think this is a myth? Ask someone to draw a picture of the sun, and chances are you'll get a yellow or orange circle in the sky. Surprise! The sun is not really yellow. If you see it somewhere outside the Earth's atmosphere, it'll look white. How come? According to NASA, the sun's temperature is the reason why it's white. The sun consists of all colors mixed together, so it appears to our eyes as white. Then why do you think we see it as yellow or orange from Earth? Colored wavelengths, which are yellow and orange, are longer, and they are the only ones that make it to our eyes. The other short wavelength colors sprawl in the atmosphere, and the sky looks blue to us during the day for the same reason. Meteorites are hot as fire when they land on Earth. What do you think, myth or fact? When people see a fireball around a meteorite, they think it's super hot. Well, this is a myth. Meteorites don't immediately land on Earth. Most of them have been in space for billions of years. Space has a cold environment, just a few degrees above absolute zero cold, you know. But don't meteorites fall into the Earth in flames? How come? The fireball is actually the air in front of the meteorite. It is compressed by the super high speed of the meteorite. The outside catches fire, but that layer is burned off on impact as a result of landing on Earth. As you would probably guess, when they land, the meteorites are lukewarm at most, but not as hot as lava. One side of the moon is permanently in the dark. Do you think this is a myth or a fact? This is a myth. Oh, come on. First the sun and now the moon. Am I living a lie? So, people look at the sky and see only the bright side of the moon. The reality is the Earth shines equally on all sides of the moon as it rotates and orbits the Earth. Half of the moon is in shadow, and half gets sunshine similar to Earth. That's not true. Similar to Earth, it doesn't have a permanent dark side. The logic is simple. The moon orbits Earth, but it also rotates on its own axis. When you think about it, we're always looking at the same side of the moon. Black holes take in everything that comes their way. What is it, myth or fact? Black holes don't have infinite mass and gravitational force, but still, no one really knows for sure what happens to the things pulled into them. Experts do know black holes do not have supergravity, though. Let's imagine this. If there was a black hole as big as the Sun, it wouldn't immediately eat the whole planet. Imagine black holes as vacuum cleaners. It does draw in a cloud of dust near its range, but other specks of dust remain where they are. So even if there was a black hole replacing the Sun, all the planets would continue to orbit similarly. They wouldn't go into the black hole. If a star or something else got into the range of the black hole, only then would its gravity affect the star. When you call someone, the signal bounces off a satellite. Is this a myth or a fact? Yep, it's a myth. Or rather, an urban legend or misconception, you name it. I mean, there are some satellite phones, but we, regular people, don't use those every day. Although your mobile phone works in a much different way. When you call someone, the nearest tower connects you to the other person online. This is why there are tower connections, huge networks of tower-to-tower connections, and hidden cables. The moon has no gravity. Any guesses? Myth or fact? This is an urban legend. Ask any astronaut you know. If you don't know any, just trust me. There is footage proving that the moon has gravity. When I say the moon has gravity, don't think it's similar to the gravity on Earth that makes the apple fall. The moon's gravity is only about 1/6 of Earth's. How does it feel to walk on the surface of the moon? The second man on the moon, Buzz Aldrin, mentioned it's like moving in slow motion and, quote, perhaps not too far from a trampoline, but without the springiness and instability, end quote. The sunset on Mars appears blue. Do you think this is a myth or a fact? This is a fact. Magnificent sunsets. The sky is filled with different shades of yellow. Now imagine this in blue. According to NASA, sunsets on Mars would look bluish, watching them with bare eyes. It's because of dust. Dust particles closer to the sun appear in blue tones. There is something called moonquakes. Does it sound like a myth or a fact? It's a fact. Quakes happen on the moon too, and they're called moonquakes. They have different features, not really similar to the quakes on Earth though. A planet can be hot enough to vaporize rocks. Any guesses? Is this a myth or a fact? This is a fact. The temperature in this universe is indeed very high. There's a planet, the temperature of which is enough to melt and even vaporize rocks. It's 2 times bigger than the Earth. This super-Earth is similar to our planet, but it is way too hot. Experts believe that it possibly has oceans of lava and clouds that rain molten rock. 1 million Earths can fit inside the Sun. Do you think this is a myth or a fact? This is a fact. Although the Sun is one of more than 100 billion stars in the Milky Way, which is at the heart of our solar system, it can fit 1 million Earths. Yeah, it looks small when we see it from here, but it's only because it's so far away from Earth. All comets have tails. Myth or fact? It's true. Some comets simply don't show their tails. They look like someone threw a snowball into space. Space is completely silent. What do you say? Shh, I knew it was too easy. This is a fact. Space doesn't have an atmosphere, so there's no way to hear any sound there. Mercury is the hottest planet. Myth or fact? Mercury is the closest planet to the Sun, so this should be a fact, huh? No, not really. Venus is the hottest planet in our solar system and the second planet from the Sun. But the distance from the Sun isn't what defines the temperature. The heat depends on the atmosphere. So Venus's atmosphere consists mostly of carbon dioxide and some nitrogen. This combination makes the atmosphere very thick. When I say thick, I mean it. Throughout the year, the surface of Venus maintains a temperature of around 860 degrees Fahrenheit. Mercury's surface resembles the temperature of a desert, but is much higher in terms of temperature variations. Venus spins clockwise. What do you say? This is a fact. Venus spins in the opposite direction compared to many other planets. The Sun rises in the west, and its rotation is very slow. Venus needs 225 Earth days to complete its spinning around the Sun. The planet's distance from the Sun affects the duration of one rotation. It's too close to the Sun, and the Sun has a strong, noticeable pull on the planets. Footprints on the Moon can stay there for millions of years. Do you think this is a fact or a myth? Fact checked. The Moon has no atmosphere, so there's no wind blowing, and without the wind, there's no way to erase the footprints without any intervention. So, how many points did you get? Let me know in the comments. That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright side.